All right, so continuing on with our warm-up here, we we were given this equation in the warm-up, and we were told to plug in 0 for x and solve for y, and we got this point 0.03. And then we were told to plug in 0 for y and solve for x, and we got this point 0.30, and then we graphed that line. Now the problem says to solve for y to find the slope-intercept form of the equation. Solving for y, remember the slope-intercept form is y equals mx plus b. And that is called the slope-intercept form of a linear equation. And so we need to get y by itself, that is solving for y. It's on one side of the equal sign by itself. So that's what we need to do in this equation. So the first thing we do is this 4x is over here with our 4y. So we need to get rid of that. In order to move it to the other side of the equal sign, we subtract 4x from both sides. Now, when we subtract 4x from the left, it just leaves 4y. And when we subtract 4x from 12, well, those cannot be combined together. So they have to remain as separate components in our equation. And I'm going to write the subtract negative 4x first because that's closer to the slope-intercept form of the equation. Now I have 4 times y, the inverse operation of multiplication, because we need to get that y by itself. So to isolate it, what we need to do is we need to divide by 4, because the inverse of multiplying by 4 is dividing by 4. Now, on the left-hand side, that's pretty easy to write, but on the right-hand side, you can do it a couple ways. You can just say the whole thing divided by 4 like that, or you can say, I'm going to divide this part by 4, and I have to divide that part by 4. You have to divide both parts by 4, so I prefer to break it up so that I remember that I have those two parts. That's just the way I do it. So I have y is equal to negative 4x divided by 4 is negative 1x. And then 12 divided by 4 is 3. So if we look at our equation, here is our point 0.03 that comes from the slope-intercept form of the equation right there. And we can also see that our slope is negative 1. And I'll just go in between the 2 points there, our intercepts, our x-intercept and our y-intercept. And notice that our delta y, our change in y as we go from the point on the left to the point on the right, we go down 3. So our delta y is negative 3. And our delta x, our change in x as we move from left to right, is to the right 3. So our delta x is positive 3. So that means that our slope, which is always calculated as delta y over delta x, is equal to negative 3 over 3, which is negative 1, which we can see right there. Questions there before we move on? All right. So this is the general form, slope-intercept form of a linear equation. And again, I'm just going to remind you that the slope is right there, the y-intercept is right there. We say that the slope is a coefficient for x. It's a number that is in front of our x. And the x and the y, those are our two variables. Actually, let me break them apart because this is our independent variable. Holy cow. It's our independent variable. I hope someone was going to correct me on that. And our y is our dependent variable. So that's the general form of a linear equation in slope-intercept form. So you get the slope and you get the y-intercept. Last week we learned the point-slope form of a linear equation. And again, we are given the slope and we are given a point. So this is any point on the line. And I hope you guys are taking notes. Any point on the line, x1, y1, or m is the slope. Our x is still the independent variable. And our y is still the dependent variable. So that's why we call it the point slope form of a linear equation. There was a question on the work last week that said it was about the equation for the slope. Remember, this equation for slope is y1 minus y2 over x1 minus x2. And the question was, how is that slope, let me resize that a little bit, how is that slope similar to this equation? And here is what we were looking for there. Notice that we're multiplying m by everything in parentheses. So if we divide this whole side by the parentheses, then what we have is y minus y1 divided by, we're dividing by this, so that's going to be in the denominator, x minus x1 is equal to, all that will be left is the m. And look how much that looks like the slope, the equation for slope. Isn't that interesting? Questions? All right. Let's pause right here. And if you're watching at home, you can take a moment to pause as well. Stand up and move your body. In the standard form of linear equations, we have some number times x plus some number times y is equal to some number. Now, There's an important thing about those numbers, A, B, and C. They have to be integers. Does anyone know what integers are? Yeah, it's a whole numbers. So, and what that means is, so go all the way back to negative infinity, and then like -3, -2, -1, 0, negative infinity up to 0, and then continues on 1, 2, 3, and so on, all the way up to infinity. So those are the integers. So A, B, and C cannot be fractions unless it's like 12 over 3. That's a fraction that is also an integer. Okay, it's just an integer represented as a fraction. It's like dressed up in clothes. All right, so with those other two forms, slope intercept, point slope, with both of those forms, you get useful things about the graph just by looking at the equation. You either get the slope and the y-intercept, or you get the slope and some point. Here, you don't get anything. Why is it useful then? Great question. You saw in the warm-up that we could pretty easily find the x and y intercepts by plugging in. You find the y-intercept by plugging in 0 for x and then solving for y. You get the x-intercept by plugging in 0 for y and solving for x. So you can get the x and y intercepts pretty quickly. That's nice. So what I asked was why standard form? So what I want you to do is to think about this word problem for a moment. We'll read it together, and then I'm going to give you a moment to think about it. At the state fair last year, of course, at the state fair last year, I was buying dinner for my extended family, like cousins and aunties and things. I spent a total of $77. My cousin wanted to pay me for his fries. I couldn't remember how much each order of fries cost, but I did remember that we ordered 5 hamburgers for $7 each. And I knew we got 8 orders of fries. So how much should he pay me? Think about how to write an equation here, and then we'll talk about it. So pause the video if you're watching this at home and see if you can write an equation. All right, Elliot, so you have some idea of how to solve this. What did you come up with? Yeah. Mm-hmm. Yep. And what is that? That's right. But it might not be a whole dollar. Well, let's see. 2 out of 8, that's 0.25. That looks right to me. $5.25. All right, awesome. That's great. You know what, Elliot? That's great solving. Good job. Does anyone have a way to see what Elliot did and write an equation for it? I'm trying to just show where everything came from here. Okay, so here's one way we can think of this. We have we need to think of the cost of the hamburgers and the cost of the uh, fries separately. So we know that there were 5 hamburgers, and those hamburgers were $7 each. And we're going to add to that. So notice this is the 35 right here. We're going to add to that the cost of each fry. We don't know what that is. We're looking for it. Times $8 per fry. So look, we take the 77 and we subtract the 35, which is right here. We subtract the 35. And then we're left with 42 on the left-hand side because 77 minus 35 is 42 equals 8 times the amount for the fries. So we divide by 8, which is right here, 5.25 per fry. So another way we can kind of think of this is, listen, if we have $77, or we have, let's just say the cost for any order will be $7 times however many hamburgers we buy plus 5.25 times however many fries we buy. So, how's that work for folks? Does that work well? Any questions there? Notice that this right now is not a whole number. If I multiplied the whole equation by 4, it would make that a whole number. We're probably not going to be super strict about that being a whole number right now, but in general, standard form, those are whole numbers, integers. All right, so why standard form? It's great for finding x and y intercepts and graphing. We saw that in the warm-up. It's often used in linear word problems. Number is equal to a number times a variable plus a number times a variable. Standard form. And we're going to be doing systems of linear equations later on next semester, and we're going to need these standard form equations then. So especially when we do systems. When there are two kinds of things and two aspects, number and cost of two things. Number of hamburgers ordered, cost of hamburgers ordered. Number of French fries ordered, cost of French fries ordered. So that's two kinds of things, two aspects, number and cost. Number and weight. Number and how much something can hold. So these are really typical kinds of word problems that we see. And we often have to convert to slope-intercept form. So standard form is not very helpful when we look at it. So we're often asked to convert to slope-intercept form, which we are most comfortable with, but we rarely have to convert to standard form. Questions on why standard form is useful? Okay. So here we are given a standard form equation Does anyone look at this and think, wait a second, is that really in standard form? Don't we need a number there? And I say, well, there is a number there. What number is there? Yeah, that's a 1. All right. So to find the x-intercept, can someone remind me what we do to find the x-intercept? We plug 0 in for y. So to find the x-intercept, plug 0 in for y. And then we solve for x. Well, that is x equals 7. Oh, it's already solved. Wow, how lucky. So that is the point 7, 0. So we plugged 0 in for y, so that means our y value has to be 0. And when y is 0, x must be 7. So when y is 0, x is 7. So we have a point 7, 0 right there. Now we're going to find the y-intercept by plugging 0 in for x. So we plug 0 in for x. And now we solve for y. So we have 2y equals 7. To solve that, we're going to divide by 2, and we'll get y is equal to 3.5. So that tells us that when x is 0, we plugged 0 in for x. When x is 0, y must be 3.5. So we have that point. So when x is 0, y is 3.5. That's about right there. And now we can just connect those 2 points with a straight line. Oops, let me use a... right there. And we've graphed. So can someone tell me, how do I find an x-intercept when I'm given a standard form equation? Yep, and then solve for x. Thank you, Elliot. Someone else, how do I find a y-intercept when I'm given a standard form equation? Come on, be brave, somebody. Plug 0 in for x, and then solve for y. All right, here's another one. I'm going to pause the video right here, and if you're at home, you should pause it and give this a try. Let's go through this together. To find my x-intercept, I'm going to plug 0 in for y. And then solve for x. So I have 8x equals 72 because this makes a 0. That's why we do it. Dividing by 8 on both sides. And I get x equals 9. So we have the point 9, 0. And I can plot that point right there. To find my y-intercept, I plug 0 in for x. And then solve for y. Again, this makes a 0, so I have negative 12y equals 72. And I divide by negative 12 here. The result is y is equal to negative 6. So my point is 0, negative 6. So the reason why it's 0 again is because I've decided that x was going to be 0. And when I decide that x is 0, it allows me to solve for y, which determines the point. So I have the point 0, negative 6 right there. And now I can connect those 2 points with a line. It might be useful to note that what the slope is. So if I think of the slope triangle, my delta y is up 6. My delta x is to the right 9. So that means my slope, which is always delta y over delta x, is 9 over 6, which is the same as, because 9 and 6 are both divisible by 3, 9 divided by 3 is 3, 6 divided by 3 is 2. 3 halves, which means go up 3 to the right 2. Oh, wait, did I? Oh, I did that backwards. Someone should have stopped me. Look, my delta x is 9, not my delta y. That was not going to end up correct. I get some candy for lunch. Delta y is 6, delta x is 9, so it's 2 over 3. So up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. There we go. So we can put those points in, and the reason why that's useful sometimes, down 2 to the left 3, is so that when we connect our line, it can just be a little bit more accurate through those points in here. All right? Questions? All right. Now we're going to talk about converting from standard to slope-intercept form. But before we do that, we should move our bodies one more time during this class. So go ahead and do that right now. Take about 1 minute. So we're now going to look at converting an equation from standard to slope-intercept form. So we need the equation to look like y equals mx plus b. Y is by itself. There's an equal sign. We have some number times x, and then we're adding another number. So when we look at our equation, we need to move this x over to the other side. So we subtract x. Again, the constant 7, the number, cannot be combined with our x term there. So we have 2y, because this makes a 0, is equal to negative x plus 7. So again, notice that I put this negative x first, so we're closer to our slope-intercept form. And now we have 2 times y, but we need y to be isolated by itself. So we need to do the inverse operation of multiplication, which is division. And again, I'm going to divide each term by 2. So I get y is equal to, and this is really negative 1x over 2. So my slope is negative 1/2 times x. 7 divided by 2 is 3.5. So this is my slope intercept form of this standard equation. So any point xy pair that makes this true will also make this true. Those two equations are said to be equivalent. Questions? Can you do this? You're going to get a chance right now. So now you convert this to slope-intercept form. At home, pause your video and give it a shot. So we're going to go over this equation, converting it from standard to slope-intercept form. Again, you always want to keep in mind what the form looks like that we need to get it into. So we're going to subtract 8x from both sides. We'll get negative 12y is equal to negative 8x plus 72. Questions so far as we move through that first step? All right, divide by negative 12. We get y is equal to, a negative divided by a negative is a positive. 8 over 12, those are both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And then we have our x. A positive divided by a negative is a negative. 72 divided by 12 is 6. And there is our slope intercept form of the equation. Again, these two equations are equivalent. They represent the same line. Any xy pair that is true for this one will be true for that one. Any xy pair that's true for that one will be true for that one. Questions? Okay, we have about 15 minutes left. Now, when we're talking about linear word problems, we are going to do 8 steps. Read, think about what the problem is asking, what's it about, identify the key information, maybe by highlighting, determine the variables, write the equation, plug in information, solve, and answer the question with a sentence. These 8 steps should really help a lot with our word problems. So let's go through one together. Read. T-shirts at a flea market cost $4.50 each, and shorts cost $6 each. You have enough money to buy exactly 12 t-shirts and 9 pairs of shorts. Write an equation in standard form that models the possible combinations of t-shirts and shorts you can buy. Graph the equation. What is the problem about? Buying how many t-shirts and shorts? I can buy at a flea market. Identify the key information. So the key information here is T-shirts are $4.50 each. Shorts are $6 each. You have enough money to buy, and I'm going to do it like this. This is going to be a little bit weird. 12 T-shirts and 9 shorts. And the reason why I'm doing that is because I'm saying, listen, these all go together. That's why they're all orange. But this relates to this information, and this relates to that information, right? Now I'm going to take these and I'm going to copy them over. We're going to go to the next page. All right, now we're going to determine the variables. I'm going to use x and y variables. I'm going to let x equal the number of t-shirts purchased, and y will equal the number of shorts purchased. Now we're going to write an equation. So we know that each shirt is $4.50. So if I take 4.5, that's $4.50, and multiply it by the number of shirts, which is x. We just said that right here. That will tell me how much I spent on shirts. And if I add to that $6 times the number of shorts purchased, this will be the amount I spend on shorts. The amount I spent on shirts plus the amount I spent on shorts will give me the total. And I know that my total is equal to 12 shirts and 9 shorts. So I can say 4.5 times 12 plus 6 times 9. All right. So 4.5 times 12 is 54. So this is 54. Plus 6 times 9 is also 54. So I'm going to rewrite this equation. 4.5x plus 6y equals 108, because 54 plus 54 is 108. Now, this is not an integer, and like I said before, I'm going to be okay with that. We could multiply everything by 2 and get 9x plus 12y equals 216, but I'm not going to make you guys do that. All right, so there's our equation. Now we need to, well, there's nothing to plug in there. And there's also nothing to solve. So it just asks we wrote the equation in standard form. Now we need to graph. So there's nothing to plug in or solve. We sort of plugged in and solved there maybe. So now I'm going to take these, I'm going to copy them, take that equation, and answer the question. Well, there's no question to answer. We just need to graph. So there's our equation that we found. So we need to plug in 0 for x to find the y-intercept, we plug in 0 for x. So 4.5 times 0 plus 6y equals 108. This makes 0. 108. So we need to divide by, so we have a 6y equals 108. We need to divide by 6. And we get y is equal to 18. 108 divided by 6 is 18. So we have the point x is 0, y is 18. Next, we have to plug for the x-intercept. We have to plug 0 in for y. So we have 4.5x plus 6 times 0 equals 108. So we have 4.5x equals 108. We're going to divide both sides by, I'm going to really squeeze this in here. I hope you guys are, that it's okay. Let's see. There we go. All right. So I'm going to divide both sides by 4.5. And the result then is that x is equal to 108 divided by 4.5 is 24. So we have the point 24, 0. So we can plot both of those points. 24, 0 is right there. And 0, 18 is right there. And we can just connect those with a straight line. Now, it will be particularly useful here to find the slope. So notice that it's easy to find the delta y and the delta x. The delta x is 24. The delta y is negative 18. So our slope is negative 18 over 24. Those are both divisible by 6. So it's negative 3 over 4. So I go down 3 and to the right 4. So from that point right here, down 3 to the right 4. Right there. From there, down 3 to the right 4. From there, down 3 to the right 4. Down 3 to the right 4. And the reason why it's particularly useful here is because those are all the possible combinations that we can buy. And I should actually erase this right up here because we can't have negative of anything. It has to stop right there on the x and the y intercepts. All right. So the possible, let's see, our x was the number of t-shirts and our y was the number of shorts. So this point, this point right up here, the blue point, represents 18 shirts, 0 shorts. And down here, the red point, that represents 0 shirts and 24 shorts. So along the way, this is 4 shirts, 14, or excuse me, yeah, 4 4 shorts, 14 shirts. Did I get those shirts and shorts backwards? I think I did. X is t-shirts. So I completely flip-flopped those. Let me just do it this way. Shirts, shorts. So that is the way that we do linear word problems for standard form. And there I have one more linear word problem here, and we're not going to get to it. If you want to see that, it'll be in the notes in Canvas.